this is Alex.
And welcome back.
And today's episode is a special episode. It is a Christmas special. So Merry Christmas, everyone.
Merry Christmas, people. It's that time of the year. Oh my God, it's so quick. Time just passed so quick. It's already December now.
I know.
And I've not bought any gift for Christmas.
Yes.
Oh well.
And also in today's episode, we have a special guest. Do you want to introduce yourself?
Hi, I'm Hatti.
And you're on which course?
Oh, yeah. So I am also doing the Masters in Biomedical Sciences. That's a research master's.
Yeah, go research.
Yeah, go
Maybe.
research.
Because we all love that lab life. Am I right?
That's why we're here. We didn't want exams. So yeah, what do you want to describe your general project at the moment? Like what you're doing in the lab?
So, in a sentence, my
This is not an elevator pitch. You can take as long as
so my project is looking at the role of PGE2 in the development of obesity-associated inflammation. So, essentially what I'm doing is feeding some mice a high-fat diet, essentially fattening them up for Christmas. So in some of these mice, we treat them with an NSAID, that's a non-steroidal anti-inflammatory drug called indomethacin. And most people probably know some common NSAIDs like aspirin and ibuprofen. And how these drugs work is that they inhibit this enzyme called the COX enzyme. So there's COX-1, COX-2, and there's a slightly more controversial COX-3. But what COX does, it's involved in the pathway of biosynthesis of PGE2. PGE2 or prostaglandin E2 it's a bioactive lipid, and it's an inflammatory mediator with sort of lots of different effects on the immune system. But some of the sort of probably most well-known classical things that it does is it's responsible for some of the major hallmarks of inflammation like fever, vasodilation, that causes swelling, redness, and things like that. Yeah. So going back to my mice, basically.
Yeah, tell them about their Christmas dinner.
Yeah, so we get them all fat. And in the meantime, we give some of them indomethacin, so that prevents PGE2 from being synthesized. So by doing that, we can take a look at, by comparing those, we can see the importance of PGE2 in developing inflammation following obesity. Because, like, obesity, you get fat, you get lots of fat.
Yeah, well, that describes it, is it?
Yeah, that is obesity. And, but fat isn't just this sort of, tissue that just sort of sits there and does nothing, Well, it does all sorts of things like regulate energy, metabolism, and homeostasis, but it also produces a lot of different factors that influence your immune system and cause inflammation. For example, PGE2.
So tell us about your mice. How many mice do you have?
I have 24 mice. That's 4 groups of 6.
All right. Are they all the same breed?
Yeah, so they're one of, I think, the most commonly used laboratory mice. So, oh goodness, I really should know, but Black 6 mice, they have a name, but
they have some, the name is really technical, so I think we're just going to abort that mission for now.
Going back to the mice, can you tell our viewers the ethics behind using mice and how you were restrained to only 24 mice, and if you had to have special training to be able to use the mice?
Well, when it comes to ethics of using mice, the sort of number one rule is don't use them when you can. So obviously the first thing you'll try and do is find alternative methods that don't involve using live animals. But sometimes, you have to when you're doing in vivo models of various diseases. So
is it like if you want to imitate a human disease, then you use a animal model instead of like a tissue culture?
Yeah. So for example, last year in my project, I investigated certain pathways using an in vitro model, just using cells in a dish, and no mice were harmed. But this year, I'm actively treating them with a drug while they're alive, and that should mimic what happens in the human body. Although obviously that is a huge stretch, and mice in a lot of ways are nothing like humans. But we try.
I mean, that is the main difference between in vivo and in like cell culture, because you lack the three-dimensional structure of whole organs, and I mean, you can't really replicate a whole body in a petri dish. Not yet.
Yeah, not yet. Yeah. So you start off from doing like a tissue culture in a petri dish, and then you move on to using animals in your experiments. How do you feel about that? When you first time handling animal, how do you feel? Were you confident about it, or were you scared?
Well, my first time handling animals, I mostly just tried to not think about my hamster, I guess.
Oh, I used to have a hamster as well.
I never had a hamster. I had a cat. It's incompatible with hamsters.
Oh my god. I used to have 2 hamsters and 4 cats. And then one of my cats ate my hamsters, and I don't know which one.
What?
Well, like they managed to open the cage. I don't know who opened the cage, the hamster or the cat, because I woke up like my hamsters are gone with just like blood and fluff everywhere in the cage.
Thank you for the graphic descriptions for our viewers.
Oh my goodness. Is that PG? Is it appropriate?
Well,
I mean,
it's
we didn't
life.
describe in detail, but
Well, it is the circle of life, isn't it? If you create a food chain. Because I have a dog at that time as well as cats and
are you going to tell me
hamsters.
the dog ate the cat afterwards?
No, my cat was fine. Like my cat kept bullying my dog though. Like she go and scratch my dog's nose when she's bored.
I think we went on a bit of a tangent here. Let's go back to our main subject. So, what are the expected results of your project?
How is it translated into human? Let's say if you give the drug to human.
So, what we hope
what you hope
that
to achieve
by once we understand the role of PGA2 in induction of various immune cells, particularly, then potentially a lot of obesity-associated disorders, such as, diabetes, type 2 diabetes, that is, even some cancers, they're associated with inflammation due to obesity.
And certain cardiovascular diseases.
Yeah,
And like artery clogging from cholesterol.
Yes.
Yeah, high level of cholesterol. Interestingly, from my research, I found out that high level of cholesterol may associate cognitive impairment.
It can associate with a variety of ailments in the human body, because it does not have just one effect. Like one thing does not have one effect on
It's
one
like a
part of the
snowball,
body.
isn't it?
It's like it has an effect all over the body. It just accumulates over time. It's like a silent, deadly bomb. And once it's reached that threshold, like boom, 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 all over the body, and you're like,
That reminds me of a Venga song.
what?
Venga song. Boom, 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 boom. I want you.
Going back to main subject.
Sorry for the distraction.
Second time this episode.
I'm sensing the dynamic here.
Yes.
Alex is the one who's got this on track.
Yes.
Yes, thank you very much, Hatti. That's what friends are for.
I'm the one pulling the train. She's the one trying to get it off the racks.
Farah keeps it, keeps you on your toes.
Yes.
Keeps the fans guessing.
Yes. They keeps them at bay, ready for anything that could happen. Mostly confusion.
I'm confused. So Hatti, what's your next plan for your master's project?
Well, we're not quite there yet, Farah. We've still got 2 months and a bit of project left. We still need to finish this one.
Really? I thought we have to like do it by now, no?
No. We have to do it in February. Or at the end of February. That's why we get a week off.
Oh, well, no one's told me that we need to apply for our next master's project yet, so...
Exactly.
Maybe I just imagined that in my head.
It's because you think we already fast forward there.
Yeah, maybe. Yeah.
See, viewers, this is another example of Farah confused.
Yeah,
And
I'm
Farah confusing the rest of us.
Yes.
Yeah,
And
that
it
works
happens-
very well.
It happens on a daily basis.
Welcome to our life, guys.
This is life in labs. So, Hatti, would you want to describe your relationship with like the people in your lab and if you're enjoying it and, just a general feeling?
Yeah, I'd say I am having a great time in labs. I love doing lab work. I love being around. And our whole lab have a really good dynamic. So
That's
we
great.
get on really well. So my main supervisor, my PI, is never around. I think most PIs are sort of never around in the lab. But so I have my direct supervision daily is by one of the postdocs in the lab.
Do you want to give a shout out?
Yeah, shout out to Mari. Best postdoc ever. Whoop, whoop. Who I just bailed on for an hour to come record this. But,
Priorities. Yeah, so would you to incoming students, would you say, yes, please do join this lab, you have a great time, or would you recommend seeing elsewhere?
Well, no, would recommend. But honestly, one of the most important things, I think, especially for undergrad students in particular, would be that when you're scouting out potential supervisors and potential topics, it's not all about the topic. A supervisor can make or break your topic and your project.
Very
rather.
true.
Yeah, you don't just choose a project, you choose the people you're working with.
Yeah.
This is very important. This applies for master's projects, undergrad projects, but also PhDs.
And also postdoc.
Yes.
Well, so on and so forth.
Yeah, until the end of your
Drop
career.
dead.
Or retire.
Yeah, probably that. I don't know, I think I might die before I retire.
Don't be so gloomy.
It's so stressful, but continue, Hatti.
Yes, so...
So you're going to promote this lab group, eh?
Yeah.
So you brought in a paper today. Do you want to talk about it?
Yeah, share with us about this paper.
Yes, so I was told to bring a paper along with me.
Some homework.
Yes, homework. I thought I was over that, but clearly not.
No.
Oh, it is a journal club kind of podcast too. It's not just about the life in labs. It's about, making the public join in the feel of the life in labs. So, part of doing experiments is also reviewing, literature papers. And it's quite important to do so because, you're not doing something that someone else has already done and found results on.
Yeah, that's one of the most important things you do first, isn't it? You always write a literature review. Shout out to all those kids on the Biomed Masters who have just all handed in their lit reviews this week, I hope.
Yes.
Yeah, I did. With
I was
tears.
told afterwards that you could ask for an extension and it didn't matter, you would be awarded it straight away. So I was like, yes, thank you very much for telling me that after I've submitted it.
That is very useful information,
Exactly.
isn't it? Well, but it is useful for your future.
No, it's not, because the dissertation will have to handle it in time because we don't get, it's just the literature review as it was wasn't a formative, it wasn't marked. We could just submit it whenever.
You can get an extension on your dissertation as well.
Yeah, if you have some
but,
special circumstances.
Oh yeah, but you have to, be ill.
Yes. Or
You have
special.
to.
Throw back to that time I had tonsillitis during my dissertation hand-in.
Ugh.
It was exciting.
I handed in my dissertation 2 days before my birthday, and it was the best 2 days of my life because I didn't have any homework to do, and I was celebrating my birthday a free man. Literally, I was like, I'm free. That's it. I'm done.
Done with this, and you're back doing masters and more dissertations.
Yes.
You played yourself.
I know.
Yep.
So, do you want to talk about the paper?
Yeah, so this paper was published in Nature Communications in 2013, and it's from the Naramiya lab in Japan, and it was actually, first author on it is my supervisor. Shout out to Chenkan for writing a funky paper.
So what you say, your supervisor comes from China?
Yes, and I think he did his either PhD or postdoc, I'm guessing, in Japan from the looks of this paper. I've never thought to ask.
That is intense.
Cool. Now you know.
He's literally studying halfway around the world.
Yeah, he's a well-travelled man.
Yes.
Agreed.
This is like the best illustration of how scientists know no borders. And it doesn't matter if you're in Edinburgh, in Japan, science is a universal language.
It's amazing, isn't it? I think that's one of the hallmarks of, a good lab. There's, I mean, just in my lab, I'd say you've got a solid, I think you cover most of the continents, really.
Well, yeah, like in my lab, there's German people, there's some people from India, there's some people from the US, there's me that's from France and England, like all over the place.
Mm-hmm. Just on my bench, let me think. Well, there's me. I'm from Glasgow. Best place on earth. My postdoc is French.
Shout out to France.
And
see, that is interesting. This is how research is an international kind of thing. Everyone dips in and helps and does their bit, and we get to the end product, which is discovering the new advancements and what you could call the dark matters of each field, because we don't know what it is until we discover it.
That is true, yeah.
So coming back
to quite a diverse community.
Indeed.
Yeah.
Let's come back to the paper Hatti brought in.
Yeah, so this paper, it's called Prostaglandin E2 Promotes Th1 Differentiation via Synergistic Amplification of IL-12 Signaling by CAMP and PI3 Kinase.
And in layman's terms?
Bit of a mouthful. But so, as I mentioned earlier, PGE2, a lot of different functions in immunity, but one of the things it does is that it promotes the production of T helper cells.
Which is it the immune cell?
Yes.
Yeah, well...
It's a white blood cell.
All right, okay. I graduated many years ago, can't remember.
Yeah, okay. It's a white blood cell. The T helper, you said?
Yeah, T helper.
So these are kind of guys that orchestrate all the different attacks against the antibodies and whatnot. No, actually, antibodies is outside, but antigens.
All right, okay. Continue, Hatti.
Yeah, so T cells, Th1 cells are a part of the T cell family, which is one of the major mediators of adaptive immunity. So you have innate immunity, and that's sort of responsible for acute inflammation. The first signs of inflammation you see, it's all innate immune cells being recruited to the injury. And then what takes a little longer is adaptive immunity, and that's T cells, B cells. They are produced, they're more specific, but they take longer. And so how this paper works into that is, so traditionally it was thought that CAMP or cyclic AMP, it's a pathway that was originally thought to suppress T cell receptor signaling, and this kind of signaling is essential for T cell differentiation, essentially. So because PGE2 was known to promote cyclic AMP, it was thought that consequently it would suppress T cell differentiation. And in 2009, I think it was, this lab and at least one other found that in fact PGE2 promoted Th1 differentiation, and this paper sort of confirms how it does that. So CAMP suppresses T cell receptor signaling, but in fact this suppression can be overcome by simultaneous activation of PI3 kinase through the PGE receptors EP2 and EP4 and or CD28.
So how does this paper fit in the literature?
So what it does is that it, by clarifying this molecular mechanism, of Th1 differentiation. It has sort of major clinical implications in developing CAMP modulators as immunoregulatory drugs.
All right. Okay, that's interesting, isn't it?
Yes.
It utilizes like our own immune system.
Exactly.
Right. So
Thank you for bringing the paper in.
yeah, thank you for coming. Thank you for sparing time for
Yes.
us.
You're welcome.
and
This
to
was fun.
Talking to the customers. No,
No, so thank you for
listeners.
Yes,
Well,
talking to the listeners.
listener. Right.
And,
So we would like to wish all of you
A Merry Christmas.
a Merry Christmas.
Merry Christmas.
And we
And-
should release a new episode just before the new year, so we'll wish you a new year then.
And keep listening to us.
Yes, please share within your
subscribe us,
networks.
follow us, and
Any scientists among our listeners, please share within your labs and networks. And if you want to be a part of this podcast, please send us an email at studentlifeinlabs@gmail.com.
yeah, that's us. And we're looking forward to be with you again
Yes.
New Year.
Yeah,
After
we'll
the
see you
New Year,
soon.
yeah.
Thank you for participating and see you
Thank
next
you.
time.
See you next time.
Bye.
Bye.
Bye, and thank you for having me, guys.
You're welcome.
Welcome.
Anytime.